Personal finance practice problem using Excel. Inflation and estimated increase in personal expenses. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We have the information on the left-hand side, going to populate that into the blue area on the right-hand side. Information saying that we're going to estimate the personal expenses per year, costing us then per year for personal expenses $66,000. We're going to assume that there's a yearly inflation rate of 5%, and then ask ourselves how much we're going to need in 2 years in order to cover the same kind of personal expenses given the inflation. So we're going to use our same kind of future value calculation to estimate how much we will need, but we're going to use it a little bit differently because most of the time when people think about a future value calculation, as we saw in the past, we use it to basically estimate how much growth there might be in something like an investment, like a savings account, like a stocks or bonds, or our home going up in value or something like that. Now we're applying it to something which is going to be the inflation, meaning how much is the inflation going to be impacting how much we'll have to typically spend for the same amount of goods in 2 years. So quick recap on inflation. That's going to be the purchasing power of the dollar going down. And notice there's going to be times in the economy, and I'm usually speaking from the standpoint of the U.S. economy, but the same will be true around the world with regards to inflation and the currency and purchasing power of the currency. In the U.S., it can be fairly stable when compared to other countries. Just note that that doesn't mean that that you won't have to experience in your lifetime time periods where inflation basically goes up and time periods when inflation goes down. So when we're doing long-term planning, we want to make sure that we're taking into consideration the likelihood that in our lifetime we're going to have to experience increased and decreased inflations, and we might have extended periods of higher inflation and extended periods of lower inflation. Both those two extremes make us feel like that's always going to be the way it is, like that's the new norm. And as soon as we feel like that's the new norm, something often changes to change the new norm to something else. So note the Federal Reserve in the U.S. usually shoots for inflation of about 1 to 3%, meaning they actually want the purchasing power of the dollar to go down by some systematic component to make sure that there's enough money, currency in the market, in the economy, in order to meet the needs of kind of like the lifeblood of the economy is cash. So they want to make sure that they have the right amount of cash there. But they try not to let it go too much over that, 1 to 3%, and they look at that closely. But again, the fact that we try to do that doesn't mean it couldn't get out of control at some point in time. So we want to kind of account for that. So we're going to assume 5%, which is above kind of the norm in the U.S., which would be 1 to 3. But like I say, it's nowhere really out of control. 5% is still within the realm. If something got out of control, you could have, very extreme interest rates, which hopefully doesn't happen. But, that's the idea here. So the idea then being, if I'm spending my money today on a basket of goods, the things like food and whatnot, and it cost me $66,000, and the money that I have is going down by 5% in terms of purchasing power, then how much will it cost me to live the same in terms of my consumption to spend the same amount of money? So we're going to do our future value type of calculation in a similar way as we did in the past. To do that, let's first take a look at our running balance calculation, which is a useful thing to give us more context than simply a future value kind of formula or function. So I'm going to do our running balance table. I'm going to start at period 0, 1, 2. We're going to use our autofill to autofill the rest of the way down. So I'm going to select these 3 cells, going to put my cursor on the fill handle and drag it on down so it continues on the series to 4 periods down. Going to center this by going to the Home tab up top, going to the alignment, and then we're going to center it. So there we have it. I'm going to start with the investment out here in F2. We're going to continue on with our practice of not typing in the 66,000 at period 0, but saying equals. I'm hitting the left arrow on the keyboard, left, and up to get to cell B1 and enter. So we're going to do a same kind of calculation as we saw if I was to think about this as an investment that was going up. but now I'm thinking about it as the expenses that I need to cover and how much I'm going to need in order to cover those expenses if we assume the purchasing power goes down. So we're going to say, all right, that means that I'm going to take that 66,000 times the 5% increase. So let's do that this way. This equals left up times, I'm sorry, that was right and up, and then times left to the 5%. So F2 times B3 and enter. Now I'm going to do an absolute reference later so that we can copy it down, but before we do it, let's just calculate it straight away a few times. So that means that we had 66,000 before, and now it's going to cost us another 3,300 after year one. If there's 5% basically inflation, that means it's going to take $69,300 to purchase the same stuff that we purchased last time, like food and gas and whatnot, or personal expenses that cost us the $66,000 last time. Now remember, that doesn't mean that everything's going to go up exactly the same. Sometimes food will go up more, and sometimes gas will go up, and something could go up and down. But we're trying to get a broad idea of how much we're going to need in our total basic expenses categorization by broadly categorizing what inflation will be. Also note, when you talk to inflation or listen to people talking about inflation, they will often use terms like it's going to be a short-term inflation or transitory or long-term kind of inflation. And in order to basically lock into what they're really concerned about for the economy, long-term inflation problems, they often eliminate things that are the things you actually spend money on, like food, electricity, gas, the things that are actually kind of important to most people oftentimes will be taken out when you consider the impact of the entire economy, because they're trying to find out what the long-term inflation indicators will be, and trying to determine if inflation will be short-term. But whether it's short-term or not, if your food costs go up, and your gas, then that's going to be a problem, and you want to, calculate that and take that into consideration. So the numbers that you'll hear then from the Fed or from news anchors and whatnot will be a kind of, you can't really go off it completely all the time because they're looking in terms of the broader economy oftentimes. In any case, we're then going to do this again. This equals the 69.3 times, and then we'll pick up the 5% again. So now it's going to go up by another 3,465, and then I'm going to say, all right, that means that we had last time equals up ones to the 69,300 plus left ones to the 3,465. That means that now it's going to cost us 72,765, and notice this starts to go up quite quickly at even a modest rate of inflation of the 5%. It's going to cost us 72,765, whereas in period 0, 2 years ago, it only cost us the 66,000. Let's do it again. This is going to be equal to the 72,765 times the 5%, left, up. Now it's going to be another 3,638. This is going to be equal to the 72,765 plus the 3,638. And now it's going to cost us 76,403 to get the same amount of stuff, which way back in period 0 cost us the 66,000. Let's go ahead and do this with a running balance calculation. So I'm actually going to delete these items, do it one more time, this time the easy way so we can calculate it quickly. I'm going to delete these items, do this first one again by saying equals right up to the 66,000 times left the 5%. Now that 5% is outside of the table. Anything that's outside the table, when I think about copying it down, is something I would think that I might need an absolute reference for. I'm not going to do it yet. I'll do that in a second just to prove that I will need it. And then we're going to say this equals the one above it plus the one to the left of it. And so there's the 69.3, which is the 66,000 plus the 3,300. Let's go ahead and copy this down, and we'll see that we have a problem when we do so. So I'm going to select these two, put our cursor on the fill handle, left click on it, drag it on down, and we have a problem because that shouldn't be 0. That shouldn't be 0. What should it be? Well, it should be taking that number. That looks right, but this 5% is wrong because it moved it down, and it should be 5%, and it's not, so we need to fix it with an absolute reference. So I'm going to delete these second two here, selecting them, deleting them. I'm going to fix this one before dragging it down again. Double clicking on it, there's the 5% in cell B3, putting my cursor in B3. We want to absolutize it, which isn't really a word, but I think it works. I'm going to put F4 on the keyboard to make it an absolute reference, which is the proper phrase. $sign before the B, $sign before the 3. You only need a mixed reference, but an absolute reference is kind of easier to understand because it basically means we're telling Excel not to move that cell down. Dollar signs having nothing to do with dollars, simply code for Excel telling it not to move the cell down. Enter. Then I'll typically select these two and move it down one cell just to double check that it's doing what I want it to do if I'm kind of not sure that it will. So we'll autofill that down. It does look right. Let's double click on it. That looks like it's doing what we want. Looks good. Let's drag it on down to year 4 then. Selecting these two cells, putting our cursor on the fill handle, dragging it on down to year 4. So year 4, we're up to $80,223 to buy the same stuff, the food I need that would only cost me $66,000 like 4 years or 5 years ago or something like that. Things are getting out of control. The world's going to hell in a handbasket these days. I remember when I used to be able to buy a hamburger Happy Meal. Anyway, okay, so now I'm going to hide some cells. Let's do this with just the future value calculation instead of a running balance. To get over there, we're going to hide some cells. So I'm going to put my cursor on column D. We're going to hide the columns, left click on it, and we're going to drag on over to column G, let go. I'm going to right click on those selected areas and hide them, practicing our working within Excel so that we have our data set right next to where we're going to be working once again. Let's do our future value. This time I'm going to do it just for 2 years out. So we're going to say 2 years out, how much would we need if we had $66,000 to pay for the stuff that we want this time, and we want to buy the same food and gas and whatnot, and there's a 5% inflation. How much would we need 2 years out? Well, we can do simply the future value calculation instead of a running balance calculation, although the running balance calculation does give us that more detailed information. So I'm going to say this equals the future value, FV, Shift 9, and then I'm going to use my keyboard. So I'm going to go left, left, left. We're looking for the rate, just like it says right here in our little data thing. So we pick up the rate, that 5%. I'm not going to type in 5%. I want to pick that up from the data because that's the proper way to set up an Excel worksheet, because then we can check and we can say, well, what if it was 6%? What if it was 3%? And we can see what's going to happen and run different scenarios with it. So then I'm going to say comma, number of periods. The number of periods we're going to say is 2, which I'm going to pick up in our data set down here as well instead of just typing 2. So I'm going to say down, 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 down on the arrow, left, left, left. There's 2. Comma. Now it's not a payment because this is not an annuity. We're saying it's the same $66,000 that's going up. We're not talking about multiple payments. Therefore, I'm just going to put 2 comments to move on over to the next argument, which is the present value. Present value is the starting point, which is the $66,000. I'm not going to hard code it in there, but rather go down, left, 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 and up to get to that $66,000. We could close it up with the brackets here, but we don't need to because Excel will do that for us. I'm just going to say enter. There we have it, although it's negative. If we don't want it to be negative, we can flip the sign by double clicking on it. You can see the brackets are now closed automatically by Excel. You could put a negative before the present value, which is probably the most proper way to do it, but I like to put the negative right before the future value on these present value, future value ones because it's the easiest thing to see. In essence, multiplying the whole thing times -1, flipping the sign. So that means 2 years out, we can expect to pay $72,765 to eat the same amount of stuff and get the same gas and driving around that we did now. So we got to take, obviously, that's important. Got to take that into consideration when planning here. So we got the, let's do this with a table format. We could do that with the table down here. So we could do the same thing with a table. So let's say we have the amount in year 1. And let's imagine that was the $66,000. And let's imagine they took away our Excel and they took away our calculator because it's some kind of test question, or they're just mean and they took away all of the stuff to make the calculation easy. But they gave us this table down here so we don't have to do it with math. So they're not totally cruel, but you know, they made it a little bit harder. So we're going to go down here and say, all right, it's going to be the rate's 5% and it's going to be 2 periods, 2 years out. Notice this rate and the periods on this table, and meaning also note we have to have the proper table, which is the future value table as opposed to the present value table. It's not an annuity table, which would be a series of payments, but present value of 1 or future value of 1 table. The rates do happen to line up to years here because that's what we're talking about, years, and the periods then will be years. But note you can use the same table if you're talking about any other period as long as the rate aligns up to it. In other words, if you were talking about half years for like bonds or something like that, then you'd have to make sure that the rates that you're looking up here would represent half year rates, not the typical yearly kind of rate, and then the table will still work. Okay, so we're taking the 5% 2 years out. That on the table gives us 1.1025. Notice that this is rounded to 4 digits out, so it's not quite as exact from the table because there could be multiple decimals for the actual number, so we're going to be rounding 4 digits out. So that's going to be 1.1025, and I'm going to add decimals here by going to the Home tab, Number Group, adding 4 decimals, decimalizing it, as I like to call it. So we're going to say the table amount, not an actual term, decimalizing, but I think it just sounds good. Home tab, font group, underline, and then we're going to say then that's going to be the amount for year 2 or 2 years out, which is going to be equal to up to the 66,000 times up 1, the 1.1025. That gives us our 72,765 once again. Now we're going to do it one more time. Let's do it with the formula, same calculation, but with a mathematical formula. We're thinking that our instructor now, we're at a school most likely, and they're making it they're even crueler that they took away our calculator, they took away Excel, and they didn't give us any tables, and they still make us do it with a formula, like a paper and pencil, like we're in cavemen, like it's any case. So we're going to hide the cells to get over to column K, putting our cursor on H, dragging over to J here so that we can hide these cells and be working right next to the data we're working on. Right click and hide. So now we're going to be putting this formula, future value equals the present value times 1 plus R to the N. So R's being the rate, N being the number of periods. I'm going to put this into an Excel kind of format table, the same thing, algebraic item into a table. You could type it out algebraically, of course, and just enter the data this way. It would be the future value would be the unknown, would be future value is going to be equal to the present value, 66,000 times, where's the times thing, times, and then 1 plus the rate, which is going to be 0.05 or 5% caret to the 6, caret 2. We're doing 2 periods out. So you could do that and then solve it that way. I think it's useful to put it into a table, and a lot of these calculations you might actually start to visualize in a table. So even in a test question scenario, you might start to visualize it in a table format. So if that's helpful, that's helpful. It's good to do in practice to work on putting things into tables because it can be useful depending on what you're doing that way. So I'm going to take this information. I got 2 major components here that I want to multiply together. So when I imagine putting that into a table, kind of like we would do for like a tax worksheet or something like that, or some type of Excel worksheet, I want these 2 on the outer column. Any other details, such as the 1 plus R to the N, I'm going to bring inside to a sub-calculation. So we're going to have then the present value in the outer column. Present value in the outer column. I'm going to pull the data over from our sheet, so equals the 66,000. And then I'm going to pick up a subcategory, which is going to be this other side. Because it has other stuff involved in it, I'm going to make a subcategory of the 1 plus the R to the N periods, colon, indicating I'm going to pull that into the inner column, and then the end result will be in the outer column, which we can then multiply together. This is a similar format that you'll see in financial statements and whatnot, useful to kind of get an idea of how you might structure these things and how you might read these things once structured. So we're going to say 1, and then the rate is going to be the 5%. I'm going to take that from the table over here, not type it in. So equals left, 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 up, up, and enter. Going to make that a percent in that cell by going to the Home tab, Numbers Group. You could add decimals. There's the 0.05, or you could make it a percent by moving the decimal 2 places over, adding the percent, and I do that by clicking this little percent thing. And then font group and underline, and that's going to give us then the 1 plus the rate. So we can sum that up. The 1 represents 100%, of course, and the 5%. So this equals the SUM. You got to know that sum function. Shift 9. I'm going to do this just with the keyboard. Up arrow once, holding down Shift, up arrow again. and then I can close it up if I want to. You don't have to because Excel will do it for you, and there it is. Let's make that then a percent. Go into the Home tab, number group, add some decimals. It could be 1.05, or you can reflect it as a percent, which would be 105%. Then we're going to take that to the number of periods, which is going to be the number, I'm going to say 2n periods. And that's going to be 2 periods that we're taking it to, 2 years out, we're going to assume. I'm going to take that from our data tab over here. So equals the 2. Going to underline that by going to the Home tab, number group, underline it. And that's going to be our total here, which is going to be, I'll type that out again. It's going to be 1 plus the rate. And then we take that to shift 6, the n periods. And then I put in periods here. And that's going to be in the outer column now. So this is the final calculation. So I'm going to bring that into the outer column. So this whole half is now outside here. This equals left, up, the 105%, shift 6 for the caret, which is to the power of 2 or squared, and enter. So there we have it. Now we're going to make that, add some decimals to it by going to the Home tab, numbers group. Let's add some decimals. It's going to add a bunch of them. It could go on for quite some time. We're at the 1.125, and that'll give us the end result of the future value, which we're looking for here. This times this outer column. Now let's underline this first, just to add some more suspense. Font group, underline it, and then we're gonna multiply the outer column. Equals up to the 66,000 times this number we got to there, and enter. There it is again, 72,765. Let's just do some formatting just to shore this thing up. I would like this colon means that we brought it to the inside for a subcategory calculation. Let's go ahead and indent it just so we can redundantly indicate that same thing, that this is a subcategory of that item up top, by going to the Home tab, alignment, indent, and then I'll indent this one again, indicating that now we're bringing that to the outer column. Home tab, alignment, indent again. There we have it. Let's go ahead and unhide some cells between B and K here so we can see all the wonderful work that we have done. Let's go to our B, left click on it, drag on over to K, and then let go. Right click the selected area and unhide. And so there we have it. So we had the 72,765 here. We got the 72,765 there. We got the 72,765 here, and the 72,765 here, representing once again what we really need to take into consideration when we're doing budgeting in the future. The fact that the value of the dollars that we're going to be spending will typically be going down if you're in the U.S. somewhere between 1 and 3, possibly 1 and 5. And if we are in a place of higher inflation, as the U.S. is subject to from time to time, even though you might have long periods without that, then it could be higher than that. And we just want to take that into consideration, of course, especially when we're taking long-term planning into consideration for our budgeting